Hello students, in this lesson let us study about the classification of lime. So the lime have been classified based on two categories. The first category is based on how much of percentage of calcium oxide and clay impurities are present. In this we have three categories: the lean or poor lime, hydraulic lime, and the poor rich or fat lime. So that we will study in detail moving further. The second classification is based on the IS code. The code which we follow for the second classification is IS 712. Now according to this, there are totally F classes from class A to class F of lime. So we will in detail see about each one of it in the coming slides. So as I told you, according to the percentage of calcium oxide or clay impurities, the lime has been divided into three categories. The first category is the lean or poor lime. Now, this generally consists of CaO along with the MgO. So this plus quantity will be somewhere around 85%. In this, the MgO should be less than 5% and the clay impurities of about more than 7% will be in the form of either silica or alumina or the iron oxide. Generally, this type of poor lime will get set on observing the CO2 from the atmosphere. Okay. See, it has many important characteristics. We'll discuss one by one. The first one is, in this case, the slacking of lime will take more time, and also the hardening and setting also will take more time. So because the slacking will take more time, it will hydrate very slowly. The type of lean or the poor lime will hydrate very slowly. Okay, next is the expansion of the lean or poor lime is generally less when compared to the expansion of the fat lime. And the color of this particular lime is varying in the range of yellow to gray. Okay, so these are some of the characteristic of the lean or poor lime which you should remember. The next thing is, where are we going to use these type of lime? So if you have any poor and inferior mortar to be made, then you can go for this particular type of lime. Especially if your construction work is of less important structure, then you can go for this. If it is very important structure, then you cannot use the lean or poor lime in the making of the mortar. Okay, so this is the first type. Second type is the hydraulic lime. So how we get this hydraulic lime is, we will do the burning of raw limestone. So generally the burning is done at 100 to 900 to 1100 degree centigrade. So burning of, let us write here, raw limestone. Generally the type of limestone which we use here in the manufacturing of hydraulic lime should have very small proportions of clay. So the clay may be in the form of silica and the alumina. These will be in the range of 5 to 30%. And what will happen here is the iron oxide, which is formed in the chemical combination with the calcium oxide content, that is CaO plus MgO, should be in the range of 70 to 80% with your MgO less than 5%. Okay, so this is how it is formed. Now, whenever you are doing the slaking of this hydraulic lime, you should be very, very careful, and you have to make sure that sufficient water is provided for the slaking of this lime. Because if in case you produce more or excess water in this particular lime, what will happen is there are all chances that this type of lime will get very, very hard soon. Okay, now depending upon the percentage of clay in these particular hydraulic lime, it is further classified into free hydraulic lime or free hydraulic lime. Secondly, the moderately hydraulic lime. And thirdly, the eminently hydraulic lime. So this feebly hydraulic lime will have 5 to 10%, very less than 5 to 10% of silica and alumina. Also, it will slack very slowly. That is after 5 to 15 minutes of adding the water to this particular lime, it will slack. And generally, the setting time is 21 days for this type of lime. So wherever damp places are there, we can go for the use of these particular type of lime, especially for your less important structures. Next is the moderately hydraulic lime. Now here 10 to 20% of impurities will be present in these particular type of lime. Here this will finish the slaking in 1 to 2 hours, and the setting time is around 7 days. And we can use this in damp place constructions. Okay. And finally, the eminently hydraulic lime. So here the clay impurities are around 20 to 30%, and it slacks very, very slowly. Slacking is basically very difficult. So its initial setting time is around 2 hours, and the final setting time is about 48 hours. So we can use this particular type in damp areas as well as in all the important structures. We can use this particular type of hydraulic lime. The next and the third one is the pure, rich, or also it is called as fat lime. So it is generally a very soft kind of lime which has CaO plus MgO more than 85% and MgO less than 4%. This is obtained by the calcination of either pure limestone or marble or white chalk or oolitic limestone or calcareous tufa. This type of lime is also called as whitewashing lime. So in this type of lime, the impurities should not be more than 5%. The impurities of clay as well as the stones. See, this fat lime is nearly a pure calcium oxide, and whenever you hydrate this with the water, required amount of water, what will happen is a solid lump will be falled apart and powder form will come into picture, or it will be reduced into the fine powder of CaOH2, and a very high heat of hydration will be liberated during this process. Generally it will come in the form of clouds of steam. So this type of lime also will absorb the CO2 from the atmosphere and sets. There are different characteristics of this type of lime which we have to understand. So let's list them one by one. The first one here is the slacking is very vigorous here. Vigorous, or what can I say? Very fast. So what will happen to the volume after slacking is it will increase by 2 to 3 times. Second is it sets slowly whenever it comes in contact with the air. So therefore it cannot be used for thick walls or where the climate is very wet. You cannot use this particular type of lime. The third one is whenever you keep it under water, it will not lose its plasticity. So if pure lime or fat lime or rich lime, this is kept under water, doesn't lose its plasticity, or it will not even set or not even harden. So the specific gravity of this fat lime is somewhere around 3.4. Right, next we have to understand where we can use this particular type of lime. So we can use this majorly for making mortars, for the matrix for concretes, for the base coat for distempering, and for the base coat of whitewash, in manufacturing of cement, also in your metallurgical industry. See, in all these places you can use the pure rich or the fat lime. Next is according to the IS classification, the major category. This is according to IS 712. Now we have, I told you in the initial part only, we have A to F category. Okay, so totally 6 categories are there. 1, 2, 3, 4, 5 and 6. The first one is called as your eminently hydraulic lime. So this is generally used for making the mortar and concrete for construction and the foundation work. Basically for all the structural purpose, whatever kind of mortar is being used, there we are going to use this particular type of lime. Now it has different characteristics. So everywhere for characteristics, I'll note it as CHA. Okay. So the first one is the color, which is generally gray. Secondly, calcium oxide is in the range of 60 to 70%, and the clay is in the range of 25%. Next, slacking is very, very difficult. It slacks very problematically, and the setting and hardening is very rapid, especially underwater. So the initial setting time for this particular class A type of eminently hydraulic lime is about 2 hours, and the final setting time is about 48 hours. Note everywhere where I'm using IST, it is nothing but the initial setting time, and this is nothing but the final setting time. Okay. Now moving on to the second one. So the second one is what? The semi hydraulic lime. Now this is also used for mortars, especially the masonry mortars, flooring, and for making of concrete if it is a ordinary work or construction, and also for plaster undercoats. We are going to use this particular type of lime. Now the characteristics here are the color, again it is gray. Calcium oxide is in the range of 70%, and clay is in the range of 15%. Both slaking and setting are very slow in case of the semi-hydraulic lime. So, and it almost take about 1 week to set underwater. Next, the third type is the fat lime. Now, it is used for all the type of finishing coat in the plastering work. It is used for whitewashing. We can use it as mortar also, but along with the lime, we have to even add pozzolana so that we can make the mortar out of it. Okay, now the characteristics of this particular lime is the color of this is generally white, slakes very vigorously or rapidly, you can say, and also the volume increases by 2 to 3 times after the slaking has been done. Okay, and the third important point here is The calcium oxide is in the range of 93% and the clay is in the range of 5 to 7%. So this is the third type of lime. Moving on to the class D or the fourth type. So we are using this again for the finishing coats in the plastering as well as whitewashing. So moving on to the characteristics. Color is white. It contains calcium and magnesium oxide in the range of 85%. This generally slacks very quickly or promptly, you can say, on the exact particular time. And fourthly, it sets very slowly. Moving on to the fifth type, that is the class E, which is nothing but your concur lime. This we usually use for the making of the masonry mortars for plastering and whitewashing. Okay, the characteristics of these type of lime is the color, again it is white in color. So the calcium oxide present in this particular type is about 20% and the magnesium oxide and other impurities is in the range of 5%. Okay, so this slacks as well as sets very slowly. Both slacking and sletting are slow in this case. So the class F or the sixth one is silicaceous dolomite lime. So this generally is used for the undercoats and finishing coats of plasters and all. Okay. So these are the 6 classes from class A to class F according to the IS 712. The more details like what are the compressive strength, tensile strength, workability, okay, soundness, all those things, that is both the chemical requirement and the physical requirement of all these 6 variants has been given in the further lesson where we will be studying about the testing of lime. Okay, so you can watch the next lesson for the details of this. It is given in the form of a table. So I hope the lesson is clear. Thank you.